Hello. Hello. Uh, yeah, online students, can you just confirm that you're able to hear me? Hello. Yeah, okay, thanks. Thank you.
Yes, sir. Yes, sir.
Okay. Do you have any doubts about what we did in yesterday's lecture? Okay. So,
No,
yeah. Hello. Yeah, so should we start for today? All of you are settled? Okay. So, to just recap what we did, yeah, thank you. So, just to recap what we have done in the last lecture, we have seen what is long run production function, okay, and we have seen what is a short run production function, okay, and we noted that for the long run production function we have three important types of returns to scale, which are increasing returns to scale, constant returns to scale, and decreasing returns to scale. Okay, whereas these yeah, any doubts or difficulties with this? Have you understood everything? Increasing, that you double the inputs and observe what is happening to the total output. Okay, now one important, so if you look in page number uh, 50, there's a diagram which is a little complicated diagram, so I have not done this diagram, but just remember, on the y-axis they are saying returns to proportionate returns, and on x-axis you are talking about scale of production, that is how much output is and inputs are being increased. So when it is rising, it means it is increasing returns to scale. Okay, when it is sort of plateauing, that is constant returns to scale, and when its increase is less than proportionate, it is called decreasing returns to scale. Okay, but not a very intuitive diagram, so don't bother much about this. Okay, even this table is not so easy to read. Okay, yeah, in today's lecture what we want to do is that another very important law of production, which is called the law of variable proportions. Yeah, please come. It's called the law of variable proportions, and remember why these two laws are very important. Our returns to scale, okay, returns to scale will help us derive the long run cost curve, okay, and the law of variable proportions, that is the short run law of production, will help us derive the short run cost structure. Okay, so it is very important for all the things that we do in future that you understand the two laws, okay, the returns to scale and the law of variable proportions. Have you all got this? Okay, so to describe law of variable proportions, I need to do the following thing. Okay, law of variable proportions. Okay, why is this called law of variable proportions? I will tell you immediately. When we write the production function Q, as a function of, let us say, two inputs, capital and labor. Okay. Now this law of variable proportions applies when, say, capital remains fixed. That is, you cannot change that input. Capital remains fixed and labor is the variable input, and labor is the variable input. Okay, so in this production function, I can show that capital is remaining fixed by one notation where I draw a line, a horizontal line above K, which means capital remains fixed and labor is the variable input. Have you got this idea? Did you all get this? Okay, so now what the law of variable proportion says is that, suppose capital is fixed and we keep increasing labor input. Okay, so you can think of it like this. In the production function, capital is remaining fixed and labor is increasing. What will happen to the output? Can you tell from intuition what will happen if we keep increasing labor? Output, what will happen? It will increase, absolutely right. So when labor increases, output will also increase. Okay, but see what is happening. If capital remains fixed and labor keeps on increasing, what is happening to the ratio of the inputs? Numerator is capital, it is remaining fixed, and labor is increasing. What will happen to the ratio? Capital per worker will increase or decrease? Numerator is fixed, right? And the denominator increases. What will happen to the ratio? Imagine करा ना, so 50 है, हे 1 है, 50 by 2, 50 by 3. What will happen? What is happening to the ratio? In first case it is 50. Next it is 25. Then it is how much? 17. Correct? Around something approximately 17 or 16. Correct? What will happen if it becomes 4? Labor input becomes 4. It becomes 12.5, right? So what is happening to this ratio K by L? Is it remaining constant? The ratio K by L continuously changes. Okay? And therefore this law is called law of variable proportion. Did you get this? One input is remaining fixed and you increase the other input, the ratio capital by labor is changing, and therefore this law is called the law of variable proportions. Okay, so let us now see what this law. Okay, originally the statement for this was given by Marshall. Okay, what he observed was, imagine a field. Okay, this is an agricultural field where land is constant. Okay, imagine this farm is being cultivated with the help of labor and capital, tractors, other equipment. Okay, if you keep increasing labor and capital and the output is, let us say, wheat or rice, what will happen to the output? As you keep adding the inputs of labor and capital, you will see that the rice output will also increase. Correct? But this land size is fixed. So if you keep on increasing labor or capital, this rate of increase increase in output, what will happen to it? The rate of increase in the output will at some point decrease. Correct? Why? Because your land size is remaining fixed. तुम्ही किती पण capital labor और उसको apply करो, at some point the additional output that you will get will start decreasing, and this is what Marshall called as the law of variable proportions. Okay, it's a simple idea, and we want to capture this with the help of diagrams. Okay, more than anything else, we'll be trying to look at it from a graphical point of view. Okay, so have you all got this? Okay, to draw the diagrams and make things clear, I will define one very important idea, which is I will define marginal productivity. Okay, marginal product. Okay, and since we are keeping capital fixed, I will describe marginal product of labor. Okay, and it is simply, we can write it as MPL. It is called a marginal productivity of labor. Okay, what is marginal productivity of labor? It is the additional output. It is the additional output from one more unit of labor. Okay, the additional output from one more unit of labor is called marginal productivity of labor. Okay, we'll write the formula for this, but I want you to do one very simple exercise. I hope that will, if in case you're feeling, if you're feeling sleepy, you will get up. Okay, imagine this is labor input and this is output. Okay, I'm just taking hypothetical numbers. Okay, and correspondingly I will write output. Okay, next to this, make another column and compute the marginal productivity of labor. Are you all able to read this table? L is the input of labor, Q is the output of output. Assume that K is remaining fixed, constant, it's not changing. That's why I have not shown it here. Okay, I want you to calculate now what will be the marginal product of labor. Okay, so look at the first row of the first two rows of the column. For 0 units of labor we cannot calculate because additional unit of labor is 1. Okay, so from 0 to 1 my output has increased from 0 to 30. So I'll do the calculation here. What is the output when input is 1? It is 30, and when it was 0 the output was 0, so this is 30. Okay, so I'll say the marginal product of labor for the first unit of labor is 30. Yes, now do the calculation for second unit. second unit output is 70, correct? And what was the output with 1 unit of labor? It was 30. So marginal product of labor is 40. Yeah, I think now you have got sufficient hint. Quickly calculate and tell me what will be the calculate करा. Last benches, if you want to come and sit in the first bench ना, इथे जागा है. शेवटी कशाला बसताय तुम्ही एवढं? Yeah, one of the online students, can you text the message? Yes. Do the calculation. Calculate the marginal productivity of labor. For third unit of labor, the output was 90. And what is our output when 2 units of labor used? 70. So what is the answer? 20. Got it? Yes. Sorry, I did not get it like yeah, 30, 40, 20, 10 and 5. That's absolutely correct. Barabar hai. Did you all get this? 20, 10 and 5. Okay, so the logic is just you ensure that you are subtracting it in the correct form. Kela, second nala hai. Okay, now this is what Marshall said, and there is no proof of this law. Why this law holds? There is no proof, but what he says is that when capital remains fixed, marginal product of labor can initially increase. That's possible, but eventually it will decrease. That is the law of variable proportions. Means कोई भी आप factor, if you keep on increasing it, eventually its marginal product will decrease. Did you get this? Okay, so this is a critical law, so let us try to draw the graph of it in a little more careful manner. I mean, this is a general graph of law of variable proportions. Okay, so here I will tell you some simplifications we are doing, which will greatly improve the understanding as compared to what is there in your study material. Okay, so but if you want to just in case want to follow, this is on page number figure 128 on page 49, but there is a slight variation from that diagram that I'm going to do, which will make it easier for you to understand the diagrams. Okay, So one below the other, draw two diagrams. Okay, x and y axis. The first diagram is, I'm going to call it marginal product of labor curve. First diagram is the marginal product of labor curve, and the second diagram is the total product curve. MPL curve and the TP curve. Okay, keep a little bit space. I want you to draw a nice diagram. I'm constrained by this space, so my diagram may not look, yeah. Then have you all plotted the x and y axis? Okay, once you finish your okay, so for the first diagram, on the y-axis I'm going to plot marginal product of labor, and on the x-axis I'm going to plot the labor input. Okay, this is the 0. And in the second graph I'm going to plot total product, and this is the 0, and along the x-axis I'm going to mark the labor input. Okay, now what you need to do is, see the general nature of marginal product labor curve, Marshall said, was like this. Okay, something like this. Draw a graph like this, all of you. Is it clear? What is the nature of this graph? Just it goes up and it comes down. This is how marginal product of labor will work. MPL curve, have you all drawn? Okay, now see to it that there is a point where MPL curve is reaching its a maximum point. Okay, from this point I will draw a horizontal line here. Okay, from here I will draw a horizontal line all the way down. Okay, I will say that this is okay, this is labor input L1. Correct? Till L1 what is happening? This marginal product is increasing. It reaches a maximum point here. Okay? This we will call as the stage 1 of production process. It is called a stage 1 of production process, where the marginal product is increasing. Okay, from L1 then mark this point L2. Okay, L2, and for L2 this L1 to L2 region is going to be our this L1 to L2 region will be our stage 2 of production process. Okay, here stage 1 hai, this is going to be stage 2. Okay, and this is called a stage 3. Stage 1, stage 2 and stage 3. Okay, corresponding to this L1, exactly below write L1 and L2. Okay, so have you got the three regions? What are the three regions? First region is when marginal product is increasing. Second region is where marginal product is decreasing, and third is the region where marginal product has become negative. Okay, it has gone below the x-axis. So these are our three regions. Okay, and correspondingly, let us draw now the total product curve, how it will behave. Okay, so now remember, when marginal product, just write this, if you know calculus, that is where it is, write this: marginal product determines the rate of increase in total product. Okay, if you know calculus, you will see that this is the first derivative of total product with respect to labor. Okay, marginal product determines the rate of increase in total product. Have you got this? Can I proceed? Okay, now write this: when marginal product is increasing, okay, see, look at this region L1 till L1, marginal product is increasing. Okay, when marginal product is increasing, the total product is increasing, okay, at increasing rate. It is increasing at increasing rate. Okay, so if you look at this part now, I want to draw the total product curve from 0 to L1. Total product is increasing at increasing rate. So this graph has this feature. It's like this. If you see here, the slope of this line is increasing continuously. Okay, so draw a graph like this for the first part. Let me change the color and draw it here. Purple colored graph I'm drawing. Okay, it goes on like this. Did you all get this? It is like a steeply going up. This is a curve which is having increasing slope, and the slope is determined by marginal product. So total product is increasing at increasing rate. So draw this part and exactly stop at this line where it cuts the L1. Okay, so this is your stage 1. Marginal product is increasing at increasing rate, total product is increasing at increasing rate. So the curve is like this. बराबर. Now next thing you write down, when marginal product is positive, okay, when marginal product is positive, marginal product is positive, marginal product is positive, okay, but decreasing. Graphically it will be falling, okay, is positive but decreasing. Total product increases, total product increases, but at a, total product increases but at a decreasing rate. Okay, so it is increasing but at a decreasing rate. So this is the kind of curvature of the curve it is having. This is going up, but its rate of increase is always falling. Okay, if you draw a tangent, it is getting flatter and flatter. So in the stage 2, our curvature of total product curve will change. It will go up at a decreasing rate like this. Got it? Pahilyanda it is like this, now it is like this. See to it that you are getting this graphical feature. Yes, for the offline students I will check the graphs. Online students, if you are having any problem, just text me. Done? All of you did the graph? Any problem? Okay. So this curvature, shift in curvature, mathematically you call this point as a point of inflection. It is L1 is a point of inflection. Curvature has moved from as a convex to concave. It was going like this, total product curve. It is going like this, and then at this point it changes its curvature and it becomes something like this, kind of a S curve. Is your graph seeing this curve? Done? Everybody has got it? Okay. Now the last point, okay, just the last thing about this graph that we need to know, write this. When marginal product is negative, what does that mean? Total output is decreasing. When marginal product is negative, marginal product is negative, then total product is falling. Total product is falling. When marginal product is negative, total product is falling. So once our graphically, remember, when we reach L2, beyond L2 if you look, marginal product is becoming negative. So beyond this, when I am drawing the graph, my total output will decrease. Okay, so let's check this. This is the point. From here on, just get it down like this. हा point of maximum है, इतना output is started falling. When marginal product of labor becomes negative, total output is decreasing. Okay, and this is your stage 3. When marginal product is negative, total output is decreasing. Okay, did you all get this? Have you all completed the graph? Okay, let's go to the last page of your notebook and quickly redraw the configurations. Draw small diagrams like this on the last page without any reference. Now MP and TP. Okay, see that you are able to replicate the diagram, this time without looking back at the notebook. See that you are able to replicate. If you are keeping the study material open, close it so that you don't have any reference. Draw the curvature of a general graph of general marginal product curve and total product curve. Yeah, even online students, you do that. I'm just checking for the offline students whether they are correctly getting it, and I'll continue with the session after, say, yeah, exactly 5 minutes I'm giving everybody to draw, after which we will write some details about this law of variable proportions. Okay, so just you also complete your graph, online students. Hello. Yeah, online students, have you completed the graph? Any difficulties? Okay. The rest, have you all completed? Can I proceed? Have you got this? Okay. So let us quickly write down the description of this law in terms of what is happening to the three things, marginal. So make a, wait, stage. Okay. Some textbooks also call this as a zone, stage or a zone. Both words are same, region. You can even call it region. Okay. Right. Marginal product and total product. Maybe a little bit of space you keep also for some description. Okay. Fine. So in stage 1, okay, stage 1, this stage has marginal product of labor is increasing. Okay. See, when I'm writing, I'm not trying to write the entire spelling, increasing. That will tire you down. If you try to write every single thing in full, your hands will start paining and you'll spend too much time writing. So conceptually, when you read this I and C, can everybody read this as increasing? Correct? So this is a much easier way to recall and it will remain in your memory, or even more graphical, you could just remember with the arrow, like MPL is increasing and total product is increasing at increasing rate. Okay, that is what we wrote in the first stage 1, and you can think of this as increasing at a increasing rate. Okay. See, because of the convex production function where everything is increasing, total output is increasing at increasing rate, marginal product of labor is increasing. We also call this region as region of increasing returns. Okay, sometimes we call this region as region of increasing returns, but usually it is at a very low units of labor, so firms go beyond this increasing returns. Okay, समझला it's a term why it is called increasing returns. Okay, so now come to stage 2. Stage 2, marginal product is positive. Okay, it is positive, but check what is happening to marginal product, but it is decreasing. Okay, marginal product is positive but decreasing. Okay, let me use short forms. This is to encourage you also to get into the habit of writing compactly whatever we are doing. Okay, so marginal product is positive but decreasing. Fine. It is positive, marginal product is positive but it is decreasing. total product is of course positive, it will never get negative. Total product is now decreasing. Oh, we have already written in the column, so just write decreasing there. This is total product only, so just write here total product is decreasing. Okay, got it? Oh, sorry, I'm extremely sorry, not decreasing. Total product is increasing but at a decreasing rate now. Total product, look at the graph of total product, it is increasing because marginal product is positive, it is increasing but at decreasing rate. At a decreasing rate. Okay, so it's increasing but the rate of increase is decreasing. If you get confused with this second arrow, just don't bother, just remember the first one. Remember in words, total output is increasing but at a decreasing rate. Okay, and stage 2 we will see has 3 common names. This stage is also called, this stage is called economic zone or economic region. Economic zone, or it is also called as the rational, means generally this is where people think and operate. It is also called a rational zone. It's the economic zone or the rational zone. Okay, here just write this: marginal product is positive but diminishing, but falling, is falling. Okay, marginal product is positive but falling, and therefore this law is also called, this law is also known as, aka means also known as, the law of diminishing marginal product. It is also known as the law of diminishing marginal product. Have you got this? Law of diminishing marginal product. This is stage 2. Okay, and most of the firms will operate only in this region, the rational zone. Okay, that's why it's called the economic zone or the operating region, and therefore law of variable proportions in some textbooks is directly called as the law of diminishing marginal product. Okay, so both are the same things. Fine, just the last step we want to write, stage 3. In stage 3, what do we have? Marginal product of labor is now what? Marginal product of labor becomes negative. Marginal product of labor becomes negative, and total output decreases. Total output decreases. Okay, in short form, negative and decreases. Correct? It is negative and decreases. Okay, Just for a moment think. I have, for example, 10 workers and my output is 50. Okay. If I employ 11 workers and my output goes to 49, does that make any economic sense? You're going to pay this worker salary and your output is falling. So no firm will ever operate in this region. This is only hypothetical. No firm will ever operate in the region of where marginal product becomes negative. Therefore, write this. This region is called irrational zone. It is called the irrational. It's called the irrational zone, since no firm would ever operate in this region. No firm operates in this region. No firm operates in this region. Okay, so this is what is it. Okay, let me come back to this diagram that is there in your textbook. Okay, now this textbook diagram is a little different from what we have done, in the sense that, just remember one thing. Just look at our first diagram of 0 to L1 and L2. Okay, I'm drawing the marginal product curve. Okay, so your marginal product curve is generally like this. Okay, this is how, is that fine? All of you got this? Marginal product of labor. It happens to be something like this. This is your MPL curve. Okay, so you have written what is marginal product of labor? Additional output from using one more unit of labor. So if I write Q of N, N is units of labor, units of labor. So MPL of nth unit of labor, let me write this. MPL of the nth unit of labor is what? Qn minus Q of n minus 1. एक लेबर वाढवलं तर कितना प्रोडक्शन चेंज हो रहा है, कितना लेबर चेंज हो रहा है. सपोज if n is 10, MPL of the 10th unit is Q of 10 minus Q of n is 10. So what will be n minus 1? 9. Got it? That's what this formula means. You look at the output of the nth unit minus output of n minus 1th unit of, here n is the units of labor. Okay. There is another function we can define which is called average product of labor. Okay. Average product of labor. That is defined as Q of n divided by L. That is the n, the number of units of labor. Units of labor. Okay. See, this APL actually plays no role. Okay, so I have not looked at this, and many of the advanced textbooks don't look at this APL. They look only at MPL, the marginal product of labor. But just like MPL and APL, there is a relationship that, you know, APL will be a curve like this. It geometrically will be a curve like this. Wherever MPL cuts it, that will be the maximum for this APL curve. After this, APL will start falling. Okay. And some textbooks identify that this as the region 1. Okay. That's what this book has done. It has identified this as region 1. But more correctly, it is to identify where marginal product is changing from increasing to decreasing. Okay. it will not matter. Most often you will get your answers right whichever diagram you follow. Okay, but just keep in mind one thing. Another question that is very commonly asked on these diagrams is, for what, when will the when will the total product be maximum? When is the total product maximum? When is the total product maximum? Okay, maximum means इससे ज़्यादा output हम नहीं produce कर सकते. Okay, so if you look in our diagram here, it's very clear when is, at what point will we get the maximum output. Look at this diagram here. This is the point of maximum output. So what is that point? When marginal product of labor becomes 0. Okay, when marginal product of labor becomes 0, your total output becomes maximum. MPL becomes 0. Okay, म्हणजे जिथे MPL curve cut करतो x axis, this point will be the point where the total product is maximum. So it will be like this. After this it will decline. Got it, all of you? This feature you have to remember because it is asked many times in exam questions. Okay, at what output is the labor input is the total product Okay, so have you all understood this law of variable proportions? This law of variable proportions is the background of short-run cost curves that we will derive in the next lecture, not in this lecture. But from next lecture, we'll try to derive what are the various cost concepts and how they are related to the laws of production. Yes, have you got this? Okay, maybe just for 5 or 6 minutes, we have almost the time end for the lecture. Let me just see if there are any questions which we can solve, which are at the end of the textbook. Okay. Okay, there is a question here. Just remember, write the answer for this. Question number 56. Question number 56. When marginal product is equal to average product. Okay. When marginal product is equal to average product. Look at this diagram. Marginal product is equal to average product. It is at this point. What is the value of APL here? AP is at maximum. Okay, just remember AP is at its maximum. We can derive these things mathematically, but let me check if there are any more questions on this. Okay. fill in the blanks with this. Look at question number 52. A production function refers to the relationship between inputs and what? What will be your answer? Production function refers to the relationship between 52. It's an true and false thing. Production function refers to the relationship between inputs and output. Correct. Dash is a gift of nature. Please write what is the answer. Which factor of production? Yes, land. Absolutely correct. There are dash stages in the law of variable proportions. 3 stages. Can you all name them? Stage 1 is increasing returns. Stage 2 is the rational zone or economic zone, and stage 3 is irrational zone. Okay, dash is considered produced means of production. Dash is considered produced means of production. Capital, correct? Capital is the produced means of production, like machines. Law of variable proportions was developed by Marshall. Okay, he developed it in the context of agriculture. Okay, 57, the wording is confusing, don't. Okay, all factors of production become variable in long run, correct. AFC and LAC will do in the next lecture. Okay, capital that is consumed by an economy or a firm in production process is known as. Say like for example, steel is used in production of car, right? 65, problem number 65. It would be called as an intermediate good or raw material. It will be called as an intermediate good or raw material. Good which is used in the production process. ठीक आहे, एवढे क्वेश्चन्स आहेत. त्याच्यानंतर there are lots of questions about cost functions, but cost functions you have to derive only from the production function. Okay. Fine. Okay, chalo, I am stopping the lecture here. Okay, I hope you have understood these 2 laws. They will form the background of deriving long run and short run cost in the next lecture. Okay. Yeah. Okay, thanks online students. So I'm stopping the stream.